What will be humanity's first megaproject? Should NASA skip the moon and go straight for Mars? Are there any other galaxy groups, like the local group? Answers to all these questions and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops into your brain, just write it down. I will gather them up and I will answer them here. All right, let's get into the questions. DanMan6431. Lots of us know the local group, our own galactic neighborhood of galaxies. Do we know of other local groups near us, and will we collide with any of them in the future? The Milky Way is part of the local group, and this is a collection of galaxies and dwarf galaxies. And so there's three main members of the local group. There's the Milky Way, which, is the one that we're in, and it's about, say, 100,000 light years across. And then there is Andromeda, which is about 2.5 million light years away from us. It's about 220,000 light years across. So it's a bigger, heavier galaxy. And then the third member of the group is in the Triangulum constellation. It's called M33. And so those are the three main galaxies. And in the far, far future, those three galaxies, because they are gravitationally bound, they are eventually going to merge into one larger elliptical galaxy. And then we're surrounded by a couple of dozen dwarf galaxies. I mean, the most famous of these are the Large and Small Magellanic Clouds, but there are lots of other dwarf galaxies that are surrounding this collection, buzzing like bees. And so eventually, have all of these mergers and interactions within 10 billion years or so from now, all of these galaxies will finally made their merger and turn into this sort of more spherical elliptical galaxy. And so what are some other versions of the local group that are relatively near us? So probably the closest one is called the Antlia Sextans group. And that is another group of galaxies. And the closest member of that is about 4.3 million light years away. And so when you think about it, Andromeda is 2.5 million light years away. The closest galaxy of this other group is 4.3 million light years away. And in fact, astronomers kind of argue about whether or not this other group is part of the local group. And so maybe in the far, far future, it'll turn out that yes, we are gravitationally bound to this other group, and the two will come together and form an even larger elliptical galaxy. When you think about sort of the scale of elliptical galaxies out there, when, say, the Milky Way is 100,000 light years across, when you think about, say, M87, which is sort of one of the largest known galaxies, it's the one where they saw the supermassive black hole, the heart of M87, like that is close to 1 million light years across. Like it's a very large galaxy. And there are elliptical galaxies out there that are, say, 5 to 6 million light years across. So you could take like the largest known galaxy in the universe and you could plonk it in between us and that other local group, and it would just extend that entire distance. So our local group, when it finally becomes its version of a elliptical galaxy, will be pretty small, relatively speaking. So there's the Antlia Sextans group. And then the next grouping of galaxies that is clearly distinct and not due to crash into us, but is, gravitationally connected to us, is called the Sculptor group. And the closest member of the Sculptor group is about 6 million light years away. And there's some really cool galaxies in this, the kinds of things that you can see in a small telescope, because they are, only about merely 6 million light years away. We think about Andromeda, 2.5 million light years away. You've got NGC 55, you get NGC 300. Both of these are really cool galaxies, and they are about 6 million light years away. And so you've got a similar collection of 4 to 5 large galaxies with a cluster of dwarf galaxies, and they're all going to collect together, and they are too far away. So, while that first galaxy group that I mentioned might merge with us, that second one, the Sculptor group, it is too far away, and it is going to fall over the cosmic horizon in the vast far future. And then the next closest one is called the IC342 Maffei group. And it is about 10 million light years away. And what makes that group really interesting is that it's actually directly across the galaxy from us. It's partially obscured by the disk of the Milky Way. And so we don't fully know what all the members are, like sort of like a mini version of the Great Attractor. And, but it's about 10 million light years away. And those are sort of the three closest groups to the local group, and yet probably none of them will join the local group in the far future. Ian Holsworth, at some point in the history of the universe, the ambient background temperature must have spent a period between 0 and 100 degrees Celsius. Is it possible that the first life in the universe could have evolved? Yeah, so at the very beginning of the universe, the temperature was, millions of degrees, and then eventually it had cooled down by about 380,000 years to about, say, 3,000 to 4,000 degrees, like the surface of a star. And then it cooled down rapidly from there. And for about, say, and I forget the exact number, it was about 10 million years, I think 12 million years after the Big Bang, there was a time when the average temperature of the entire universe was between 0 and 100 degrees Celsius. In other words, the entire universe was in the habitable zone. But when did the first heavier elements form? It probably came later than that, probably within the first 100 to 200 million years. And so even though the entire universe would have been cool enough for liquid water to just be present in giant blobs, which would be so weird, that the actual oxygen molecules that make up water hadn't formed yet in the hearts of stars. Probably. But maybe maybe these stars formed more quickly than we think. Maybe they enriched the areas around it. And maybe you did get that there was starting to be oxygen atoms formed, that there was heavier elements that were starting to form. And maybe some kind of primitive life could have formed, and if you think of like the entire universe, you would have a lot of chances at it. When you think about how life formed on Earth, we are one planet in one galaxy. That on planet Earth, most of planet Earth is uninhabitable, but there's this sort of thin sheen on the outside of the planet where liquid water can form and life could form. But what if the entire universe, every cubic meter of it, were places where life could form? And maybe those first stars formed earlier than we think. And so maybe you got these heavier elements that were being injected into the universe, this habitable universe. And so this is a theory. There are papers on this that sort of think about this time in the early universe when it was habitable, and what are the kind of ways that these heavier elements could have been produced, and could you have life forming back then? And then the universe cooled down, and then they would all freeze to death, or maybe would be preserved, and then they would land on the planets that were forming around these new stars, and they seeded the life they seeded life into the universe. And that maybe we think about panspermia here in the solar system, where you've got life that's going from planet to planet, maybe, possibly. And maybe you could have galactic panspermia, where you've got, or interstellar panspermia, where you've got bacteria going from planet to planet around the galaxy, and maybe even going from between galaxies. And so, wouldn't it be weird? Wouldn't it be interesting if all life in the universe formed at this time when the universe was habitable, and you had sort of maximum chances of life, and that we're all just descendants from that time? Or maybe that's just ridiculous, and life formed here on Earth 4 billion years ago, which is what we have evidence for. Tommy C., what do you think will be the first mega project in space? Space rings, space elevators, huge rotating hotels, solar shields, lenses, etc.? We don't know what's going to be the first mega project. Sometimes you don't notice mega projects until after they've been built. You're like, wow, that dam in China is pretty big. I guess that's a mega project. Or, Great Wall in China, or the pyramids, or the Hoover Dam. Like there are various projects that will show up when the need is there, when we need a certain amount of power. That's when these kinds of mega projects will arrive. And so right now, there is no incentive. There's no reason for us to embark upon any of these challenges. The one that I sort of, people are always excited about this idea of Dyson spheres, of Dyson swarms, that you're going to surround the sun in a collection of, solar collecting satellites that will then use that power for some purpose for humanity. 3D assemblers, compute clusters, who knows what they're going to use that power for. And that feels like that's like the final stage. Like humanity will have colonized the entire solar system. We'll start to dismantle the solar system to build these collecting satellites that are going to orbit around the sun and collect all of the energy coming from the sun. And that is like the most that we could accomplish here in the solar system. And that would be a mega project. But what's interesting is that we've already begun that process, that we have launched satellites from Earth, made, we have torn apart pieces of planet Earth. We have turned them into satellites and we've launched them to space. And now they are collecting power from the sun and they're doing some kind of activity. They are doing science, or they're doing communications, or they are doing navigation or things like that. And so the Dyson sphere has already begun. And it won't be like when you think about the kind of infrastructure that we have on Earth, cities, highways, port systems, the internet, those are mega projects. And yet at no point did somebody go, well, I'm going to build the mega project. It's that bit by bit, piece by piece, people see value and they build these things and they add them together. And eventually you have something significant. And so we have already begun building our Dyson swarm. And it may take us a few 100 years, 1,000 years to build our Dyson swarm. But we've already begun. And so I think that is going to be the mega project that we will look back and go, we actually built that thing. If you want to support the work we do at Universe Today, consider joining our Patreon club. Your support lets us have a minimum of ads and no sponsorship messages. Patrons get no ads on universetoday.com for life. Want the extra parts of the live stream that aren't in this edited version? You can sign up for a special patron-only podcast feed and get the overtime segments, as well as other special behind-the-scenes episodes, including our monthly patron-only question show. Thanks to everyone who has already subscribed, and welcome to our recent newcomers: Castor Soyu, James Diacono, Steph One, Michael Sanders, Chet Patterson, and Katie Mullally. Join the club at patreon.com/universe today. Handsome Link, we could move all our dirty industry to the moon. There are no ecosystems or life to destroy. Absolutely. One of the main reasons that Jeff Bezos says that he started Blue Origin was to build humanity's future in space, to actually create move our polluting industries off of planet Earth and to put them into space. But again, where are we on the technology curve today? Do we have the technology to be able to move the kinds of polluting facilities that we have down here on Earth up into space? Like, what are the kinds of things that we do that cause pollution? Well, we drive cars. So could we move our cars to space? Well, then we wouldn't be able to drive our cars. So that wouldn't help. We fly in airplanes. Well, if we put our airplanes in space, that wouldn't help us because then our planes would be in space and we need them down here on Earth. We could move our shipping transportation to space again, right? Heating our homes, problem. It goes on and on and on and on and on about all of the kinds of things that we could potentially move out into space. You are left with a small group of things that you could produce in space. Like we could move a microchip facility out into space, and then we acquire the resources for the microchips, and then we deliver them to Earth. Where are we going to get the resources from? Well, we bring them from Earth to space. That is incredibly polluting for us to launch rockets to take things to space. Okay, we bring material from asteroids to the factories, and then we create the microchips, and then we deliver the microchips to Earth. Okay, now we're on the right track. But just think about the amount of technology that would be required to get us to a place where we could build chip fabs in space fed by material coming from asteroids. Like there's a lot of technology that needs to be built before we can get to that place. So the problem is that there just isn't a lot of the kinds of things that we could be producing in space yet. I think computing is a good example of a thing that we could and should be doing. Let's take our ChatGPT LLM clusters and fire them off into space and let them compute without having to, they've got direct access to sunlight. They can radiate their temperature off into space. They don't need to use our lakes and oceans to cool themselves down. That seems like a pretty feasible idea. And I've seen some interesting proposals, but even that, to launch a NVIDIA chip to space, and have them all network together and have them all functioning is complicated. What if you want to do upgrades and what if you need to reboot the thing? You got to fly to space and turn it off, turn it back on again. So, that's a joke. They know how to do that. But anyway, so I think that unfortunately, there's just not a lot of things right now today that makes sense for. But again, if we follow our inevitable technological curve, there will be a time when various things will start to make sense, and they'll start because space is the best place to make them. When you think about, say, fiber optic cables, you can make the most pure glass fiber optic cables in space where there's no impurities because there's no gravity. That makes a lot of sense. And there will be this demand for this optically pure fiber optic cable. So there will eventually be a factory in space that is producing the best. Certain kinds of drugs could be made in space under zero gravity. There's a very small list of things where there's actually an advantage, but you can only get them by making them in space. And eventually that will grow, and eventually those will require resources, and eventually you'll have asteroid mining that will be supplying them, and eventually we're going to get there. But to sort of always artificially try to push this ahead, it just costs too much money in the short term. It doesn't give us the benefits over the long term. We have to wait as our natural technology growth moves us up the chain into more and more space-based manufacturing. But we'll get there, and we'll get there inevitably. We'll get there to a scale that will boggle your imagination when we get there inevitably. We're just not there today. Adam, Musk said we are skipping the moon last week. Do you think Isaacman will be confirmed? Do you think he would stand up to Musk on some issues? So I'm recording this episode January 6th, 2025. And this is before the new administration takes over in the United States, and that means that all of the various cabinet positions, all of the leaders of various agencies will be replaced with new leaders of various agencies. And Jared Isaacman, the CEO of Polaris, has been proposed to be the candidate for the new NASA administrator. And so that's going to await a Senate confirmation where people are going to decide whether or not they're going to look at his history, look at his capabilities, and decide whether or not he is the appropriate person. And, we don't know what's going to happen. We don't know if he's going to be confirmed. When I think about all of the potential new candidate positions that have been proposed by the new administration, that is one of the least controversial. It's fairly controversial in that Isaacman has no direct experience as part of NASA, as part of the government in leading large bureaucracies, to accomplish various tasks over time. But then what is the experience of running a company? What is the experience of being an entrepreneur? What is the experience of flying to space? And sort of all of the logistical issues that were involved. I mean, I think he has on-hands experience in planning a mission, in figuring out, knowing what the limits are, knowing what's possible, knowing what's not possible. And then he put his life on the line. He actually hopped in the spacecraft and completed the missions twice and did a spacewalk, the first private astronaut to do a spacewalk. So I think there's, when I think about all of the possible appointments that are about to happen, this is one that I am ambivalent, which is that I can see lots of really interesting, good reasons why someone like Isaacman might be a lot of fun to help, maybe inject some new ideas and maybe to provide some new enthusiasm for NASA. And then at the same time, I know that there's a lot of sort of institutional knowledge that could be lost if you make too many changes to NASA too quickly, that you lose this experience, the people who built the Voyagers, the people who built the various missions that are on Moon and Mars today and across all of the various centers at NASA. So will it be confirmed? We don't know. Probably, but we don't know. Would he stand up to Musk? I don't know. Right now we're seeing that Musk is starting to have some issues, having some challenges in the interactions with other people as part of the upcoming administration. And it could very well be that that'll all get settled and smoothed out, and Musk will have a very serious effect on it. Or it's possible that he will be sidelined, that, thanks for donating hundreds of millions of dollars to help us get in power, and now we don't need you anymore. And what will be his response to that? So right now, it is such a complicated, such a time of flux that we just have no answers. And all we can do is kick back and be journalists, which is to seek the truth, try to speak to the people who are actually doing the work, who are involved in it, and report on the things that happen as they happen, and not get too sort of upset or agitated or anxious in advance for the things that are now happening. So I think that it's going to be, from a spaceflight side, if it actually does happen, it's going to be interesting and it's going to be challenging. There's a ton of challenges that anybody who takes on NASA is going to have to deal with. All of the existing stakeholders, all of the existing laws, all of the funding, all of the employment for all of these people across the United States, all of the international alliances that the United States is part of, all of the commitments that the United States has made to other countries with the International Space Station, with various rovers and missions. Like, all of these have to be considered and navigated. And it requires both a light touch to not lose institutional knowledge, and it requires like a certain level of enthusiasm and creativity and out of the box thinking. And we're going to see how these come and play together. And it could be a disaster, and it could be sort of a business as usual, and it could be revolutionary, and we don't know which one of those it's going to be. And I don't have any plans to think about it too much. All I'm going to do is watch as actual things happen, as missions are proposed, as missions are canceled, as people shuffle around. We will see what happens. Thanks to everyone who put your questions into the YouTube comments, as well as everybody who joined the live show. It's 2 hours long. We have many more questions that you didn't see here. So if you want that, there should be an event for when the next one is going to be happening. Now, I'm going to chat a bit about one of the other big shows that I work on. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Endrum Gross, Bear Lake Roofing, David Giltonen, David Matz, Dennis Alberti, Dustin Cable, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Paul Rohrbach, Sean Sargent, SpiderSop.io, Stephen Fowler-Munley, and Vlad Shiplin, who support us at the Master of the Universe level. And all our patrons. All your support means the universe to us. So I am the publisher of the Universe Today website, which I've been doing for 25 years, but I am also the long-standing co-host of a podcast called Astronomy Cast. And this is a show that I do with Dr. Pamela Gay. And I've literally lost track of how many seasons we're doing. I think we're into season 16, maybe season 17. There's 740 episodes in the podcast. And it is this conversation with me and a PhD astronomer where we talk about a different subject every week. We may talk about black holes, then we'll talk about gravitational waves, then we'll talk about various observatories and various missions. We keep it specific to that one topic and just cover that soup to nuts and give you a really good overview of the subject. People enjoy Pamela's melodious voice, tolerate my voice, but still, if you want a really interesting podcast that has been around for a long time, you will never run out of episodes. Definitely go and do a search for Astronomy Cast on any podcatching application that you use. All right, we'll see you next time.